Good morning everyone. Welcome back to my channel. Today I am going to take you a new topic in cryptography and network security. The topic is RC4 algorithm. The name RC4, it came after the scientist Ron Rivest invented this RC4. RC4 is nothing but reversed cipher. In the year 1987, Ron Rivest invented this particular algorithm, that is RC4 algorithm. This is one type of stream cipher. There are two types of cipher. One is block cipher, other one is stream cipher. And there are various examples for block cipher, that is like AES algorithm, DES algorithm, all are examples of block cipher where we will encrypt the plain text using blocks in block manner. Coming to RC4 algorithm, we are going to encrypt the plain text in a stream bit by bit manner or byte by byte. That is why it is called as stream cipher. And this algorithm is very popular and it works very quickly. That is why most of the scientists or most of the users will use this RC4 algorithm. So now we will see how encryption is done. Let us like converting the plain text into the cipher text. For encryption, here the user he enters the plain text and the secret key. So the user will be given the plain text and the secret key. By using these two things, they will be converting the plain text into the cipher text. So once the secret key is entered, this encryption algorithm, they make use of two algorithms. One is KSA, key scheduling algorithm, and PRGA, that is pseudo random generator algorithm. So using these two algorithms, the secret key is converted into a key stream. Okay, so now the secret key is converted into a key stream. So this plain text is XORed with the key stream generated by using these two algorithms, byte by byte XORing. Now we will get the encrypted text. This is how encryption is done. Coming to decryption, the same byte-wise XOR manner. We will see the block diagram for this RC4 algorithm. So we will be given with plain text and secret key. The secret key is passed to RC4 algorithm using KSA and PRGA, key scheduling algorithm and pseudo random generator algorithm. The secret key is converted into a key stream. Now the plain text is XOR with key stream to get the encrypted text. So this is the encryption process in RC4 algorithm. Now let me explain about the key scheduling, that is KSA algorithm and pseudo random generator algorithm. Okay. So here we will be using one state vector, that is state vector. It is represented by S of I, state vector. Okay, that is represented by S of I, and we will also be using one more vector, that is T of I, that is temporary vector. So first what we will be doing is that the state vector, if the size of the state vector is 256, okay, the size of the state vector is 256, the number of iterations will also be 256. Okay, so here since the size of the vector we have taken 256, how many number of iterations will be there? 256 iterations will be there. So we will be writing this iteration like this: for I equal to 0 to 255. So it is 256. We are initializing I is stored in S of I. So for every value of I, we will be storing the same I value over here. So S of I will be equal to 0, 1, 2, 3, etc. up to 255. This is how we will be initializing the state vector. Suppose if the state vector value is 8, okay, the state vector size is 8, and what we have to do, we have to write here for I equal to 0 to 7. And here it will be 0, 1, 2, 3, 4, 5, 6, 7 we will get. Suppose size of the state vector is 4 and the number of iterations will be 0, 2 to 3. So this is how we are initializing it. Next comes the main part, that is key scheduling algorithm. In key scheduling algorithm, we will be using two variables. One is I variable and J variable. Using these two variables, we will try to swap the locations of state vector. Okay, so for I equal to 0 to 255, based on the size of the array, this 255 will vary. 255 do, j will be equal to j plus s of I plus temporary vector mod 256. Okay, so if the size of the array is 8 means then we have to write 0 to 7 and here mod 8 it will come. Then now we will do the swapping between s of I and s of j. This is an algorithm for key scheduling. Don't worry, I will explain to you with an example, then you will understand what is this key scheduling algorithm. Next comes pseudo random generator algorithm. So in this algorithm, this is the algorithm you have. So first we are going to set the size of the array to the number of iteration, and I and j you are going to set it to 0. While of true, I will be equal to I plus 1 mod 256. J will be equal to j plus s of I mod 256. Then you are going to swap the value between s of I and s of j, and temporary value t will be equal to s of I plus s of j mod 256, and the key stream will be equal to s of t. This t, whatever the value you are getting, so you are going to find out s of t and that value will be considered as key value. Now the next step is that encryption. We have found the key stream. Okay, by using this key scheduling and pseudo random generator, we have found the key stream. Now we are going to do the encryption. That is nothing but plain text XOR with the key stream what you have got. And what is decryption? Decryption is ciphertext XOR with the key stream. Okay, this is how encryption and decryption is done. Now we will see one example how we are going to do the encryption using RC4 algorithm. Okay. Now we will see this example. P will be equal to 1222. So this is the plain text they have given, and the key, they have secret key is 1236. So using these two things we are going to convert into a ciphertext. Okay. Now we are going to use the state vector, that is the values, it has only 8 values 0, 1, 2, 3, 4, 5, 6, 7. So we are initializing the values with I equal to 0 to 7 and we are getting the state array vector. And how we are going to get the temporary vector? Temporary vector is got by using this secret key. So you have to write 1236. So the same 1236 you have to write, and you have to repeat the key again 1236. This is how you are going to generate your temporary vector. Okay, so now you have got both the state vector and temporary vector. Using this we are going to convert the plain text into the ciphertext. So this is the KSA algorithm. So I have explained to you KSA algorithm is j equal to 0 for I equal to 0 to 7. Since we have used here 0 to 7, I am going to write here 7, and j is equal to j plus s of I plus t of I mod 8 swap s of I comma s of j. So we will see this example now. So first initializing I equal to 0. Okay, first iteration. So in the first iteration, what is s value? S value is between 0 to 7 and temporary vector is between 1236, 1236. Okay, this is what the key we have. So what is the first value? The j will be equal to 0. Okay, and I equal to j is equal to, now it will be j will be equal to, so I is equal to 0. Okay, I is equal to 0. That means j is equal to, what is j value here? J value is initially it is set to 0. 0 plus s of I. What is s of I plus t of I? Mod 8. So what is s of I? S of I is s of 0. What is s of 0? S of 0 is 0 here. Okay, 0. And what is t of I? T of I is t of 0. What is t of 0? That is 1. So you will get 0 plus 1 mod 8. So the answer is 1 mod 8. 1 mod 8 will be 1 mod 8. That is answer will be 1. So j value will be equal to 1. So now what we have to do, the next step is that you have to swap s of I and s of j. So what will you get? Swap of s of I comma s of j. What is s of I over here? S of I is s of 0. I will be 0. And what is j? J will be 1. So you have to swap s of 0 and s of 1. So you have to swap between these two values. So what is s? S will be equal to 1, 0, 2, 3, 4, 5, 6, 7. So after first iteration, the state vector will become like this. Initially it was 0, 1, 2, 3. So after proceeding this first iteration, you are getting the state vector as 1, 0, 2, 3, 4, 5, 6, 7. I is equal to 1. So when I is equal to 1, j will be equal to is equal to j plus. Okay, j is the previous value for j is equal to, what is the previous value for j? That is 1. So you have to take the previous value. J is equal to j plus s of I, s of 1 plus then t of 1. Okay, then mod 8. So what is s of 1? What is s of 1 over here in this? 0, 1. That is 0. Okay, so it will be 0 plus, what is t of 1? T of 1 is 0, 1. That will be 2. Okay, 2 mod 8. So what will you get? You will get 3 mod 8. What is 3 mod 8? The answer is 3. So j will be equal to 3. So you have to swap the values between s of I, s of 1, this is I is equal to 1, s of I and s of j, that is s of 3. So you have to swap between s of 1 and s of 3. So when you swap between, what is s of 1? 1 is over here and 3 is 0, 1, 2, 3, this one. So you have to swap 0 and 3. So you will get s will be equal to 1, 3, 2, 0, 4, 5, 6, 7. Okay, this is what you will get when you finish the iteration 1. Okay, now we move on to the next iteration. I is equal to 2. So what will you get? I is equal to 2. So j will be equal to, the previous value for j is 3. 3 plus s of 2. Okay, s of 5. That means s of 2 plus t of 2 mod 8. So what is s of 2? S of 2 0, 1, 2. That will be 2 plus and t of 2. T of 2 is, what is t of 2 here? If you take 0, 1, 2, that is 3 mod 8. So you will get 3 plus 2, 5, 5 plus 3, 8. Okay, that will be 8 mod 8. What is 8 mod 8? That will be 0. J will be equal to 0. Okay, now you have to swap s of I comma s of j. S of I is 2 comma s of j is 0. Okay, you swap between s of 2, 0, 1, 2, this one, and s of 0, this one. Okay, what will you get now? S will be equal to 2, 3, 1, 0, 4, 5, 6, 7. Okay, this is what you will get after I is equal to 2. Okay, now we move on to the next iteration, I equal to 3. So what is I equal to 3? That will be j will be equal to j. What is the previous value for j? It is 0 plus s of I. S of I is 3 plus t of I, that is 3 mod 8. So what will you get? S of 3 is 0, 1, 2, 3, that is 0 plus t of 3. What is t of 3 here? 0, 1, 2, 3, that is 6. 6 mod 8. So you will get 6 mod 8. 6 mod 8 will be 6. So j will be equal to 6. So you have to swap s of 3 comma s of 6. That means you have to swap s of I comma s of j. Okay, what will you get here? S of 3 is 0, 1, 2, 3. This value and 6. 3, 4, 5, 6. So when you swap this, now s value will become 2, 3, 1, 6, 4, 5, 0, 7. Okay, this is what is s value. Next iteration is I equal to 4. So I have written yes, the previous state vector and temporary vector over here. So what is j value? J will be, the previous value for j is, what is previous value for j? It is 6. Okay, you have to take 6. 6 plus s of I, that means s of 4 plus t of 4 mod 8. So what will you get? That will be 6 plus s of 4, 0, 1, 2, 3, 4. That will be 4 plus t of 4, 0, 1, 2, 3, 4. That will be 1 mod 8. So you will get 6 plus 4, 10, 10 plus 1, 11. 11 mod 8. The answer will be 3. So j will be equal to 3. Okay, when j is equal to 3, the next is swap s of I comma s of j. That means s of 4 comma s of 3. So when you swap this, when you swap the 0, 1, 2, 3, 4, this value and s of 3, 0, 1, 2, 3, this one. So you have to swap between these two. So you will get s will be equal to 2, 3, 1, 4, 6, 5, 0, 7. Okay, this is what is s value you will get. Okay, after iteration 4. Next we move on to the next iteration, I equal to 5. Okay, I equal to 5, that will be j will be equal to, what is previous value for j? That is 3 plus s of 5 plus t of 5 mod 8. That will be 3 plus s of 5, 0, 1, 2, 3, 4, 5. That is 5 plus what is t of 5? You will get t of 5 is 0, 1, 2, 3, 4, 5. That is 2 mod 8. So you will get 5, 6, 7, 8, 9, 10. 10 mod 8. What is 10 mod 8? That will be 2. So j value will be equal to 2. Okay. So now you have to swap between s of I and s of j. That is s of 5 and s of 2. So what is s of 5 over here? 0, 1, 2, 3, 4, 5. This one, and s of 2, 0, 1, 2. Okay. Between these two you have to swap. Now s will become 2, 3, 5, 4, 6, 1, 0, 7. Okay. This is what you will get after your iteration 5. Now we move on to the next iteration, I equal to 6. So when I is equal to 6, j will be equal to, the previous value for j is 2 here. So 2 plus s of 6 plus t of 6 mod 8. That will be 2 plus, what is s of 6? 0, 1, 0, 1, 2, 3, 4, 5, 6. That will be 0. 0 plus t of 6. What is t of 6? 0, 1, 2, 3, 4, 5, 6, 3. 3 mod 8. That will be 5 mod 8. So answer will be 5. J will be equal to 5. Okay, now you have to swap s of I, s of 6 and s of j, that is 5. So what will you get? S of 6 is 0, 1, 2, 3, 4, 5, 6. This value, and s of 5. 1, 2, 0, 1, 2, 3, 4, 5. Okay, you have to swap between these two. So you will get s will be equal to 2, 3, 5, 4, 6, 0, 1, 7. Okay, this is what is I equal to 6. Now the last iteration, I equal to 7. So j will be equal to, the previous value for j is 5. 5 plus s of 7 plus t of 7 mod 8. So that will be 5 plus s of 7 is 0, 1, 2, 3, 4, 5, 6, 7. That will be 7 plus t of 7 is, the last value in this t of 7 is 0, 1, 2, 3, 4, 5, 6, 7. That is 6. 6 mod 8. That will be 18. 18 mod 8. Answer will be 2. Okay, j will be equal to 2. So swap s of 7 with s of 2. So what is s of 7 here? This is s of 7. S of 2 is 0, 1, 2. Okay, you swap 5 and 7. So you will get s value will be 2, 3, 7, 4, 6, 0, 1, 5. Okay, this is what is s value. This is the last iteration. So after proceeding all the 7 iteration, you have got the s values like this. Now we move on to the next algorithm, that is pseudo random generator algorithm. Next step is pseudo random generator algorithm. So I have explained to you this algorithm already. First we have to initialize I and j is equal to 0. While of true, I equal to I plus 1 mod 8, j is equal to j plus s of I mod 8. Swap s of I comma s of j. T will be equal to s of I plus s of j mod 8, and k will be equal to s of t. Now we will see how we are going to do this. Yes, we have received that state vector to be 2, 3, 7, 4, 6, 0, 1, 5 after iterating 7 steps. Okay, first we have to initialize I equal to 0 and j equal to 0. Okay, next I will be equal to, so what is I? I will be equal to, you substitute here, I will be equal to I plus 1. I is 0 plus 1 mod 8. So you will get 1 mod 8. 1 mod 8 will be equal to 1. So I value is 1 now. So j value will be equal to j plus s of I. What is j here? J is 0 and s of I. S of I is s of, the previous value for I is 1. S of 1 mod 8. So what will you get? 0 plus s of 1, 0, 1. So this is 3 here. That will be 0 plus 3 mod 8. So you will get 0 plus 3 mod 8 is 3. Okay, so j value is 3 now and I value is 1. So now next step is that we have finished these two steps. Okay, the next step is swap s of I comma s of j. So swap of s of 1 comma s of j. What is s of j? I is 1 here and j is 3. So s of 1 comma s of j. So what will you get? You have to swap here 0 1 this value and 3 0 1 2 3. Okay, you have to swap 3 and 4. What will be the s vector? S vector will be 2 4 7 3 6 0 1 5. This is what you will get after swapping these two vectors. What is the next step? T will be equal to s of I plus s of j mod 8. T will be equal to s of I plus s of j mod 8. S of I is s of 1 and s of j is 3 over here. So here what you have to do is you have to take s of 1 to be 1 itself and s of 3 to be 3 itself. So you will get 1 plus 3 mod 8. You should not consider the exact values of s. You have to take the array initialized array values. That will be 1 plus 3 mod 8. The t will be equal to 4 mod 8. So what is 4 mod 8? T will be equal to 4. Now k will be equal to, what is k? K will be equal to s of t. That will be s of 4. What is s of 4 over here? 0, 1, 2, 3, 4. The answer is 6. So the key stream which is generated using key scheduling algorithm and pseudo random generator algorithm is 6. Okay. Next, the key value, we have found out the key value to be 6 over here. So key value 6. What is the plain text? Plain text we have got is 1 2 2 2. So first we will take the first value. Okay, so we will write this 1 as 0 1 0 0 1. Okay, what is the binary value for 6? It is 0 1 1 0. So the plain text value is 0 0 1. So you have to XOR this bit by bit. So 0 1 1 0 exclusive OR with 0 0 1. You will get 0 1 exclusive OR, you will get 1. 1 0 exclusive OR is 1. 1 0 exclusive OR is 1 and 0. So the cipher text will be 0 1 1. So this is the cipher text for the 1 value. Likewise, you have to find out the cipher text for 2 2 2 using the key values. So this is what is RC4 algorithm. So in RC4 algorithm, what we have done is like we have taken. So in RC4 algorithm, we consider the plain text as secret key. So for the secret key, you are going to perform KSA and pseudo random generator algorithm, and you are going to produce a key stream. And with the help of the key stream, you are going to XOR with plain text, and you are going to get the encrypted text. In decryption also, the same thing you are going to do it. Okay, this is what is RC4 algorithm. I hope this video is very useful for you and you understand this RC4 algorithm. Thank you very much for watching this video.